All right, our next lesson is going to be about resistors. It's a pretty easy lesson. There's only a couple key points that you need to learn. First of all, and most important of all, Ohm's law. This is a law that you will use in nearly every single problem in physics when it comes to electricity. Ohm's law says that U, or voltage, is equal to R, resistance, times I, current. So voltage equals resistance times current. Easy. Okay? There's one important thing about this. There's a graph that goes with it. Okay? So for all graphs in resistance is going to be U and I. U is the y-axis and I is the x-axis. Now, resistance, Ohm's law, has a very specific graph, and the characteristics of this graph include a couple things. First of all, it's a straight line. The line isn't curved, it's not twisty, it doesn't go up and down, it's not parabolic, it's just a straight line. Second important thing is that it has a positive slope, which means it doesn't go down, which means we can eliminate this one. So it's not this graph. Third of all, and most importantly, it passes through the origin. Now, origin is where the x and the y meet at 0, 0. So for it to be a graph of Ohm's law, it has to be a straight line with a positive slope that passes through the origin. Since this one doesn't pass through the origin, we can eliminate that, which means this is the graph of Ohm's law. So now, where is R in all of this, you might ask? Well, it's hidden right here in the slope. The slope is the resistance. Now, there's another way to calculate resistance, and it lies through this formula. Resistance is equal to resistivity times length over cross-sectional area. Resistivity will often be given to you. It's not something that we need to calculate or learn how to calculate at this level. Length is pretty easy to find if you don't already have it, but cross-sectional area, I wanted to explain to you guys a bit. Cross-sectional area is the area. But what if you get the area, if you need to get the area of a wire? How do you get the area of that? Easy. Well, kind of. You need to multiply pi by r squared. Pi, you know it, it's 3.14159, whatever. You just need to plug that into the calculator. You need to put the variable pi into the you need to put pi into the calculator. Now, radius is half of the diameter. Diameter is from one end of the circle to the other. Radius is half of that. So if they gave you the diameter, you divide it by 2 and you get the radius. If they just gave you the radius, perfect, you use that, and then you square it. So cross-sectional area is often, if we're talking in a wire, this is obviously if we're talking in a wire because wires are circular and they're cylinders. So that can be written as pi r squared. Now, resistors in general, how do you calculate equivalent resistance? There's two different ways. If you're talking about a series connection where they're just all in series, it's easy, you just add them all up. However, if they're in parallel, it's a bit more complicated. See, in series, say you have 4 resistors, R equivalent, the equivalent resistance of all of them is going to be R1 plus R2 plus R3 plus R4. If you have 4 resistors in parallel, 1 over R equivalent is going to be equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4, and so on and so forth. Now here's something important that you need to keep in mind that'll help you make sure that you've done this correctly. R equivalent in series is always going to be bigger than the biggest resistance. Let's say the biggest resistance that you have is 10 ohms. R equivalent is going to be bigger than that every single time in series. In parallel, R equivalent is going to be smaller than the smallest one. So let's say your smallest resistance is 3 ohms. That's the smallest resistance of the resistors that you have. R equivalent is going to be smaller than 3 ohms. Now, on to energy, or energy and power. So energy, first of all, can either be written as E or W, just depending on how you want to use it. And it's equal to power times the total time. Now, power is equal to U times I, so energy, which is equal to power times time, is also equal to U times I times delta T. Of course, this isn't the only thing power is equal to. Power is also equal to Ri squared and U squared over R, which are all derived from its original formula. And there you go, there's a lesson of resistors.